Okay, in this lesson, we'll continue talking about initializations. A more advanced strategy is the Xavier initialization, also known as Glorot initialization. Who are Xavier and Glorot, you could ask? Well, that's one person actually, Xavier Glorot. He is the only academic I know of whose work is named after his first name, rather than his last name. Quite intriguing. In any case, Mr. Glorot, or simply Xavier, proposed this method in 2010 and was quickly adopted on a large scale. That's the state-of-the-art technique, so you probably want to get acquainted with it. So, the range for the first two cases was arbitrarily chosen by us, right? The Xavier initialization addresses this issue. There are both a uniform Xavier initialization and a normal Xavier initialization. The main idea is that the method used for randomization isn't so important. It is the number of outputs in the following layer that does. With the passing of each layer, the Xavier initialization is maintaining the variance in some bounds, so we can take full advantage of activation functions. There are two formulas. The uniform Xavier initialization states we should draw each weight W from a random uniform distribution in the range from minus x to x, where x is equal to the square root of 6, divided by the number of inputs plus the number of outputs for the transformation. For the normal Xavier initialization, we have draw each weight W from a normal distribution with a mean of 0 and a standard deviation equal to 2, divided by the number of inputs plus the number of outputs for the transformation. The numerator values 2 and 6 vary across sources, but the idea is the same. Another detail you should notice is that the number of inputs and outputs matters. Outputs are clear. That's where the activation function is going. So the higher number of outputs, the higher need to spread weights. What about inputs? Well, optimization is done through backpropagation, so when we backpropagate, we would obviously have the same problem but in the opposite direction. Okay. Finally, in TensorFlow, this is the default initializer. So, if you initialize the variables without specifying how, it will automatically adopt the Xavier initializer, unlike what we did in the minimal example. Super interesting stuff. Next time, we will challenge the gradient descent. Thanks for watching.